If we take the letters A, B, C, D, how many two-letter arrangements can we make from these letters without reusing any letter? Well, a few random examples. We could have AB, BC, CD, BD, AA. No, we can't have AA because that's using the same letter twice. DB, and so on. If we want to make sure to find all the different arrangements, we need to do it a bit more methodically or systematically. So let's try it this way. AB, AC, AD, BA. Now we can't have BB, so BC, BD, CA, CB, CD, DA, DB, DC. So these are all the different arrangements that we can have. If we count them, we find that we actually have 12 arrangements here. We could also use a two-way table to find all the different arrangements. So let's draw our two-way table. We've got A, B, C, D across the top, A, B, C, D down the side. So what are the arrangements we can make from A, B, C, D, taking two letters at a time, but not repeating any letter? AA, that's not allowed. AB, AC, AD, BA, BB is not allowed. BC, BD, CA, CB, CD, DA, DB, DC, and DD is not allowed. So we can see here very clearly that we've got all the arrangements, and we have 12 in total, 6 and 6. So that's a very neat way of doing it. We can also use the fundamental principle of counting to figure out how many arrangements are possible. So we have the letters A, B, C, D, and really we have two operations here. The first operation is to choose one of these four letters. So how many possible outcomes are there? Well, we can choose one letter from these four letters in four different ways. So we have four possible outcomes. So let's take an example. Let's assume that we pick the letter B. So for the second operation, we can't choose B again. So B is gone. So for the second operation, we can choose any of the remaining letters. And there are 3 remaining letters. So we can pick A or C or D. Let's say we pick D. So we have 4 possible outcomes for the first operation, 3 possible outcomes for the second operation, and the fundamental principle of counting says that if there are 4 outcomes for the first operation and 3 for the second operation, there are 4 by 3 possible outcomes in total. 4 by 3 is 12, and that agrees with the answers we found using different approaches to this problem. So in future, if we're asked a question like this, we don't need to list all the outcomes systematically. We don't need to use a two-way table. We can just use the fundamental principle of counting and find out the number of arrangements that are possible.